Hey everybody, James here from JC Sharp, and thanks for joining me for this week's video. Firstly, before we go any further, just want to say that I'm sorry it's taken me so long to get some content out. I've been really busy generally with just life, and I've not really had much opportunity to get some proper content fully recorded and finished off. So today, this one is a nice, quick and simple video from the other stuff that I've been working on, so that I could at least get something onto the channel so it doesn't look like it's been stale for too long. So today's video then, what we're going to be looking at, we're going to be looking at how to refactor case or switch statements into the .NET strategy pattern. So what is the .NET strategy pattern? I suppose is the first question we need to look at and answer. The strategy pattern is a behavioural pattern within .NET, and it's designed to take a family of different behaviours that all essentially fulfil the same condition, and turn them into objects so that then on the surface these objects are interchangeable and can be swapped around without sort of exploding the code or anything serious happening, but the results from which are then also different based on the underlying behaviour. So a quick look at the current code that we've got in front of us then. So we have this class for refactoring switch to strategy, and in here we've got a double method that just calculates an area of a shape. Some of this code might look familiar from the open close principle that I did a good few weeks back now. It is quite similar, and we will be making use of polymorphism, so really useful to have a look at those things before we go through this. So we've got our calculate area method, and we can see we take in a number of different parameters. And then what we do is based on this shape object, or this shape enum, which is just simply rectangle, circle or triangle, we have a variety of different outcomes. So for rectangle, we do length times width. Circle, we do pi times radius. Triangle, we do side by side by the square root of 3 divided by 4. And then the default is obviously just return nothing. So the first sort of main problem we can see with this code is that it's extremely busy, essentially. You might find in the real world that code like this can be much bigger, much longer. But the difficulty that we've got here is if we wanted to add another shape, for example, and try and extend this code, we wouldn't be able to easily. So we'd have to put in some additional parameters. We would then have to change the shape switch itself and add another condition in there. We'd also need to change the shape enum and add another shape in there. And ultimately, changing it and changing its behaviour would become quite messy. And as I've already mentioned, the idea behind the strategy pattern is that all that kind of these families of behaviour can be interchanged without any difficulty at all. Alongside this, it's worth mentioning we do have a number of tests here at the moment. So all of these tests we will run, and they currently pass. So we're just sort of calculating expected areas, calling the calculate area with the shape that we're using, length, width. You'll notice other parameters are 0 because we don't need them. And then the same for circle and same for triangle, and just making sure that everything comes out as expected. So, okay, so refactoring this then, we'll take it step by step. And one of the first things that we need to do if we're going to implement the strategy pattern, and in particular with polymorphism, we need to give each of these shapes that we're going to ultimately create a contract to work from. So we're going to start off by creating ourselves an interface, I think. So we'll call it, and this is going to be very confusing, we'll call it iShape. No, we won't, because of the enum, we won't call it that. We'll call it iShape calculator, if I can spell this morning. And within that interface, we'll just give ourselves a public double calculate area. I really can't spell this morning. We won't need any parameters being passed in there or anything like that. So this is purely the interface that we're going to be working with. So let's move that out into its own file. We don't want to add that to the Git repo. So let's work with the first shape that we've got then. So rectangle, basically. So let's create ourselves a new class, rectangle. And we're going to make this inherit from iShape calculator. There we go. I did pick it up. It was just thinking about it. So we're going to implement the missing members first of all, but then what we're going to do is expand on that. So when we create a rectangle, we're going to want to provide the length and the width that we need to use in order to calculate the area of the shape. So we'll give ourselves a constructor, and we'll also give ourselves private double length and a private double width. And then what we'll do is we'll just initialize both of those fields from the constructor so that when we create a new rectangle, we give it a length and a width. And that means then within this contracted calculate area, we can just simply return length times width, like so. Okay, so we've got our rectangle shape. We'll move that out to its own file. So now we need to work on this. So what we want in here, ideally within the calculate area, is we want to remove all of this nonsense and just leave it with that single interface, that single contract call. So we'll do this in stages. So for the time being, we'll add in here a new shape calculator, and this will be called shape calculator. And then what we're going to do at the point where we call rectangle, because we now know that actually through rectangle we're going to be using shape calculator instead of the logic built in here, we can just go shape calculator dot calculate area. Okay. Now this also means these two properties for length and width are redundant. So we can go ahead and remove those now because they're not being used by the code anymore. So that's that element done. What we do have now is a problem within the tests because we've now changed parameters. In fact, what I'm going to do is I'm going to put those length and double parameters back just for the time being. But we do now have a problem with parameters. So in this sense here, we're going to need ourselves a new rectangle being passed in at this point, and we'll give it a length of 10 and a width of 10 as it currently already is expected. So essentially now, these parameters here, they're not necessary. We're still passing them in, but they're not going to be used. So we'll also fix these tests. So we'll just pass null in for the shapes down here for the time being, because we haven't added these yet, but we will be doing. And what we should see now is that we should run the tests and these will still pass. And they do, and that's great. So now we can see that if it's a rectangle, we're going to run the shape calculator, calculate area. And this sort of defers the logic over to our rectangle class and nowhere else. Okay. So now let's remove these parameters. And again, we'll go into the tests and we'll remove the need for them in here as well. Which I think is going to be those two. There we go, and then these two. Beautiful. So once again, we should be able to run all these tests and we should see they work. Excellent. So let's go with the circle and the triangle next. So again, we'll give ourselves public class of circle. That's going to have a constructor. And then from that constructor, we're going to have a private variable called radius, not radios. We'll initialize that from the constructor. We'll inherit from iShape calculator, implement the missing member. And then at this point here, all we really need to do is copy this logic out. So we'll take that, we'll slap it in here, like so. This needs to be renamed to the private variable as such. Now we can move that out to its own file. And then again, at this point here, what we can do is we can now say, because we're going to pass in this I-shape calculator interface, this logic now can be removed. So again, we just defer to shape calculator dot calculate area. And now, as with before, we don't need the radius. So now we can go in and we can fix our test. So here with the circle, we'll pass a new circle with a radius of 10. And actually now what we can do is we can get rid of that, get rid of that, and get rid of that. So you can see as we're going now, we're starting to remove the dependency on additional parameters being passed and just tell it, use this interface, use this contract, and you'll achieve what you need to achieve. So once again, if we run the tests now, everything will pass. So we know that the logic is being deferred. We know everything's working nicely. So last one then, let's look at triangle, and then we can move on to the next stages of refactoring this switch statement out, because at the moment we still got it there, and the plan is we get rid of it. So public class, triangle, constructor, and this needs a double side being passed in. Oops. And we'll initialize that from the constructor. And then again, we inherit from shape calculator, implement the missing member. And in this case, again, we just take this logic here and we copy it straight out. If I can ever select it properly. I'm really struggling today. No idea why. Return. There we go. So we'll just pop the underscores in the front of these now as well. There we go. Beautiful. So that's the triangle. We can now move out to its own class. And then once again, because we're now deferring the logic, we say shape calculator dot calculate area as such. Okay. Now, again, we can remove these variables that aren't needed anymore. And then we go to our tests and we simply fix away. So we don't need that last variable in there anymore. And in fact, what we're going to do here now is go new triangle, and the side we're going to pass in is 10. So once again now we should be able to run all of these tests and they will all pass. Beautiful. But we've still got this idea of a switch here, you know, going on the shape and stuff like that. But the thing is, what you'll notice now is all of this code is the same. It's agnostic based on this, this enum. We don't need it. So actually what we can do straight off the bat now is return shape calculator dot calculate area. And actually now all of that code redundant, removed, and that initial variable is as well. So we can get rid of that. Now again, we need to fix the tests here. So all we need to do is get rid of these shapes at the start. And all being well now, we run these tests once more and everything passes perfectly. No issues, right? So we've got rid of that switch statement entirely and replaced it with this polymorphic version of the strategy pattern. The other thing we can do from here, obviously, is we have this shape enum now not being used. So we can go ahead and we can completely delete that class. We don't need it. Everything still builds. And in our unit tests, everything still runs. There you go. Beautiful. So what does this mean then? So in future then with this, if we ever needed to add any other shapes, it would be quite simple as turning around and saying, okay, let's add square as a bit of a joke. But again, because you inherit from the I-shape calculator, in the test aspect of it, you would just add another test. You'd pass in a new square. It defers the logic based on the interface to the class that sits underneath it. So we don't ever need to now change this. Whenever we need to introduce a new shape or anything like that, this parent class stays exactly the same. All of these stay exactly the same. They never need to change. And all we do is extend the code with a new type of shape and job done. The system does the rest. So there we go. Nice quick ditty on refactoring a switch statement to the strategy pattern and making use of polymorphism. I hope you've enjoyed the video. If you have, make sure you hit the like and subscribe and ring the bell for notifications. More content coming soon. Until next time, thanks for watching and goodbye.